So today we'll be learning about the Pandas library. It is actually a very important and one of the main libraries that you will be learning in this course, and it is named Pandas. So Pandas is a library that is basically used for statistic, basically used for analysis of any kind of data. Okay, for example, when you analyze the financial records, structural records, so that's where Pandas come into play. Okay. So it is entirely built on NumPy, as you would have learned about NumPy in the last lecture. And it primarily provides two kind of data structures. One is series, which is one-dimensional data set. You can take it as just like your rows or any kind of details. For example, you have a details of height of some people, and you only have height. Okay, no any other metric. So if you can uh, take it on a list, like one height is 164.5 centimeter, 171.5 centimeter, just like that, you will have a one-dimensional structure which is called series. Okay, and two-dimensional structure that is called data frame. Data frame is basically your tabular data. All your rows and columns create a table which is called a data frame. Okay. So what is Panda is commonly used for data cleaning, data transformation, and exploratory analysis, as you can already see in the slides. But the main problem, I'm saying problem, main thing uh, is the exploratory analysis. Okay, data cleaning, data transformation is also important, but uh, in the field of machine learning, data ex- exploratory analysis is a huge thing because from there you will learn about the data, how to tackle it, and what kind of use cases from this data can be made of. Okay, so let's see. Okay, so what is a series? As I already was saying, a series is a one-dimensional labeled array, or you can list in Python. It can hold any data type, as you can see in float and string, etc. And it is just a column. Okay, in a column you have some details. So just that single column is a series. Okay. For example, you can see on the slide, we have imported pandas, and here we have created a series. Okay. Let's see it on the code. Okay. First of all, we will import pandas as PD. Okay. It means that we will be calling pandas PD. We don't have to write pandas again and again. Just PD will be suffice. Okay. So we were created, let's just say the S for series, PD dot series, and we will give it a list 89, 34, 56, 78. Okay, these four are just random numbers, and then just try to print it. Okay, I think kernel is running a little bit slow. Yeah, see, we have imported pandas. Okay, and then we assigned a variable s to a series which contains these numbers. Okay, 89, 34, 56, and 78. So then if we what is 0, 1, 2, 3? It's basically just an index. Okay. How do you access the element? Okay. Just like list. It series also contains index. So basically this is series. You need to know about series because it is a basic block. But most of the time, I most of the times or almost of the time, almost most of the time, like I'm not finding able to word, like 99% of the time you will only be working on the data frames. Okay, because those are the main things. Okay, so there's also how to create series. Okay, as you can see, there is an example. We have taken created a series called marks for some random numbers, and there's also a parameter we are given inside is called index. Okay, John, Asha, Raj, Meena. And if we print marks there, you can see in the output that there will be indexes. Instead that, as was we were seeing in the code, is instead of the 0, 1, 2, 3, we will have names. So we can also give our own indexes. Okay. As you can, let me end it. Keep what are the key points here? Like, uh, we can assign the custom labels, and it's easy to access the labels make using these indexes. Okay. Let's do one thing. Go back to the code, and here, with addition to these lists of numbers, I will give index equal to some random name, John or Ray, Meena, and registration. Okay. See, now instead of 0, 1, 2, 3, you have John, Ray, Meena, and Shiv, and you can access these elements. For example, if I write S of John, see, you will get the number, the NP NumPy number. NP means NumPy, int 64 number. Basically, int means integer and 64 means 64 bits. Okay, it's 89. Okay, it and in John was representing number 89. See, okay, so that's how you can create your own index so that you can access the elements, or you can also access by 0, 1, 2, 3. The default index is not a big deal. It's just you know how to like create a custom index. Okay, so data frame. Data frame is the main thing. Like almost 98 or 99 or even 100% of the time, you will be working on the data frames when it comes to the machine learning data. Okay, so data frame is a two-dimensional data structure similar to a table with rows and columns. Okay, so it's a two-dimensional data which contains rows and columns. So basically, you are working on a table. Okay, each column in a data frame is a series. This is important. Okay, each column in a data frame is a series. I mean, if a table contains 5 columns, column 1, column 2, column 3, column 4, and column 5, all these columns are series. The data frame is made up of series. That's why we were learning about series first. Okay, data frame is a you can also say data frame is a culmination of series. Okay, so as you can see in the example, there is a dictionary or have keys name, math, and science. Basically, it's the name of some students with their math scores and science scores, and then we convert it into a data frame. Okay, how to convert into a data frame? By using a function called data frame and give the data as an argument, and then you will print df or whatever you how to access df. Okay, so let's go to a code. Uh, Data is equals to name, and then take a list of names. Ray, Nina, Joy. Okay, these are the names. Okay, now I will give it to another key called marks. Instead of marks, I just math. Okay, and then give it a list of marks. 89, 79, 90, and then science. 90, 89, 70. So this is a data. It's a dictionary of keys and values, and now we will convert it into a data frame. So df, which is mean data frame, you can also assign it to any variable, but df is the mostly used. It's just nomenclature. If you want to assign it to anything, you can. ed dot data frame here, give the data, and then df. Okay, see, it will show you like this. Okay, now you have column name, maths, and science, core in maths and science. Index will be 0 and 1, 2. It's not a big deal because uh, in the data frame, when you will be trying to access the elements, it will be most of the time by using the column names. Okay, so we don't need to change or give custom index. If you want, you can do by while you're experimenting with pandas, but it's your choice. Okay, so that's how we create a data frame of any random kind of data. Okay, or any data and sample data. We will also in the future lectures, if not in this lecture, uh, working on the CSV or Excel files. So most of the time, we will be converting them into a data frame and then uh, exploring data, like what kind of data that is. Okay. So understanding the data frame components. There are some key attributes that you will be using all of the time when you are working on the data frame. Okay. So first of all, df dot shape, rows and column count. So it's basically like NumPy, where we in the earlier NumPy we were using dot shape attribute to find the dimension of the array. Similarly, in this df dot shape will be getting the number of rows and columns of the data frame, like how many rows and columns are there in the data frame. Okay. df dot columns, as you can, it's just telling by its name that you will get the columns names with this. Index row labels. Uh, Index is, will basically you give you. I think it will be give you row labels. We will cover that. We will see each and everything what it's giving an output. Then we will go on to the next. And df.info data summary. It will give you the summarized information about the data, like what kind of columns do you have, or what are the column names. Just a simple information. Okay. Df.describe. This is the main thing because it will give you the statistical summary. Okay, like if you have some financial transaction data. Okay, then mean of the what is the mean of that data? Okay, like you have some column, and what is the in financial data structure, you have some columns that just say financial outflow. Okay, how much money did the how much money did get out of the account. Okay, so and what is the mean of that number? What is the average number of average amount that has gone out of the account? So that will and mean, and then what is the maximum amount, medium, and what kind of like at what time, during which time, like during which time, like which amount during which time. All these statistical data will be given by df.describe. Okay, we will see it uh, in this. We'll get to the code to see. Okay, uh, let's go to the code. Now we have already have df. Okay, now to get the shape. Okay, see, by using attribute shape, I will find like how many rows and columns will the data frame has, or the table has. Okay, so it's 3 by 3. Since we have 3 columns and 3 rows, it's a 3 by 3 data frame. Okay, with 3 rows and 3 columns. Next, we will go and do df dot columns. It will return the columns name. See, as it was showing in the data frame, name, match, and science, it is also returning a list or object of a name of the column. Okay, name, maths, and science. Now df dot index. Okay, what index is doing, it will be giving us a uh, row labels as it was written in the slide, which means like till which from which to till which index there are rows. For example, in this, it has given me range index from start from 0 and stop till 3 and step is 1. Okay, so what does this mean? Okay, so let's see. You have table this here. Okay, index are 0, 1, 2. Okay, so how many indexes are there? 0, 1, 2. That means 3. Three indexes are there. Okay, and it's starting at 0 and ending at 3. Okay, basically stop means the number which has stopped plus 1. Okay, as we were doing the range function in the very earlier of the course, and step is 1. Okay, so we from 0 we are going to 1, 2, and stopping at 3. Okay, 3 is not included in the last number, never includes in the list, but till 3. Okay, so step basically means like are we any how much is the interval, as you can say that, like 0, 1, 2. If it would be like in a 0, 2, 4, 8, then the step would be 2 instead of 1. Okay, so that's what step is signifying, like what is the interval between each index. And what was the last two? Df dot info. Okay, so it's basically returning all the details about the mm, column, sorry, of the data frame. Okay, df.info, which basically describes a summary of the data, and as well as df.describe, I think we will see it in a more kind of real world data. Then you will be able to easily understand. See, because there's nothing to like, there's nothing statistical about these data. It's just a sample 3 by 3 data. So for df.info, df.describe, let's see, let's do one thing. Okay. So I will show you the new function here. It may be or maybe not in the slides as far as I know. So for that, let's just say instead of we are you working on a df1. So what happens is like uh, most of the time you will be working on some kind of data. Okay, you won't need to create data again and again, or you will be working on some pre-built kind of data, and then what will be the format of data. Okay, so most preferred format of data. Uh, which we use in Pandas is CSV file. Okay, it's basically like Excel, but uh, slightly easier to read. CSV means comma separated. Okay, so comma separated values. Okay, so I have two CSV file here. One is art, which basically a record of heart disease reading, heart disease medical readings. So we will be working on that. For that, we have to convert it into first data frame. Okay, so how do we convert? For air, we will just use the function called read CSV. Okay, and basically here we have to give the path of the file. Okay, since it's in the same folder, so we can just write the name of the file. If somehow you will have the file in some another folder, like if you're writing code in let's just say D drive, and you have the file in C drive, then you have to give the path here instead of just name. Okay, it's CSV, and just there's another function called df1 dot head. Dot head function is basically a it will show you the top five values. Means first five values, sorry, not top five, first five values of the data. Okay, so let's see. See, now these are age, sex, chest pain type, rating BP, cholesterol, fasting BS, testing. So reach CSV function is already converted the CSV file into a data frame in the background, and we will be access only the data frame that is converted. Okay, As you can see here, this data. These are just first 5 rows of the data. Okay. So if we try to use all these functions that we use here, okay, uh, let me go to the slide first. Ah, I think I made a little bit mistake here. In the da.info, it's a attribute with parenthesis. Okay, each C. Now it's giving the details here. Like we have range index, data columns, column non name, non-null, 3 non-null values. Non-nulls mean basically there's no empty values. Okay, and there will be type of values. Okay. Earlier I didn't use the parenthesis, so it was basically returning the uh, like entire table. Uh, it's like a small mistakes keep on happening. When you will practice, it will also will happen with you. So just keep on practicing. Okay. Similarly with describe. Now it's giving yeah, because of parenthesis it was not returning a value. So it is returning a describe, which means now it will give you the statistical summary. Okay. Well, you will get the count. Okay. Now you will get the mean, standard deviation, minimum, 25 percentile, quarter percentile, half, third, it's called third, fourth, yeah, 25. These 25 percentile are percentile values. Okay. You will learn about these in statistics and what is the max value. Okay. So in the data, we have the max. Where's the data? Yeah. We have the max value in max is 90. Okay. And in science, so you also have the same value 90. So here in the statistical summary, it was showing max value is equal to 90. Then it was showing the minimum value. What is the minimum value of the column? Standard deviation, mean, count. These are all the statistical values. Okay. 25% means is called, if I'm not wrong, quarter percentile, I think. Or this 75 interquartile percentile. Basically, these are percentile values. We will learn more about them in statistics. As I was there, that's how we, and the read CSV function and the head function, that's how we read the real world data. Okay. Now, if we want, we can also use this key attributes of the data frame, shape in the in these. Oh, sorry, df.1 in this data. If I try to df1 dot shape here, see 918 and 12 columns. It means with this data can have 918 rows and 12 columns. Okay, you can count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, and it will contain 918 rows. Okay, similarly, if we go df dot columns, not df1. Yeah, see, it will return the names of list of a name of entire columns. Similarly, df, if I directly go to df dot uh, info, this time with parentheses, not if I keep on writing df instead of df1. Yeah, df1. Okay. So seeing there's like there's an it will return columns and will show that are there any null values. It, as you can see, there are 918 non-null values, and that means no value is null or empty. Or it's basically empty values are called null values. If there's some missing values, okay, then it will return the data type, like what kind of values are there in the columns. And with df.describe, as you saw earlier, it will return the statistical value, same count, mean, standard. It will return the same types of value. I am keep on writing df instead of df1. Yeah, okay. So column wise, it will return the same value, same value. I mean, in the describe, the same statistical values will keep on there, but just the data will change. Okay. Like count, mean, standard, min, 25 percentile, 50 percentile, 75 percentile, and max values. Okay. So these are the key attributes that will base most of the time you have to use these to find out details about data. For example, info comes in when you have to see like if the data contains empty values, some empty values. So you have to either remove these or what will we do with that kind of data, because if we provide some empty values or some wrong data to a machine learning model, it will behave differently, and the performance will be low. So all these removing data or putting in some random mean values in the missing values, it's called exploratory data analysis, which is the main thrust of this course. Okay, you will learn about this in the future lecture. So back to the presentation. So how do you like access the data in the data frame? So basically, if you want to column access, okay, so you can just write df.max. Max was a column in the data that we created earlier, right? So it will return all the values, okay. And if you want row access, you are access the rows instead of columns. You can use a function called log, or you can use a function called ilog. Okay. So what is the difference between log and ilog? Ilog. Basically, what is like r- log function use the access matter by index. Okay. So as you can see here, data. Uh, these are the indexes 0, 1, 2, 3, 4. Okay. Log function will use df1 dot. If I use log, it will start with 0. Okay. See here, this is the data, first row. Okay. Here, it will show it printed like this. Okay. With columns and their values. And if you use ilog, now instead of 0, we will have to give 1. See, or instead of now 1, I will give 2. So it will print the second value. Now, because uh, log function use the access method by index, and ilog function use the index method by position. Okay, so it is the first row. Okay, by position, it is the first row. Are you getting it? And by index, it is a zeroth row. Since index start from 0 and we have already assigned this index 0 by default, if you use log function, we will get, let me write it here, df1 dot ilog. Okay. Oh no, ilog, matlog 0. And here instead of 1. Okay. Let's see. Okay. As you can see, this is the same data. Wait a second. Not same. Log is 0. Let me check. Yeah, log is 0. Ilog is 1. Okay. Age is 49. Okay, like I think there's some mistake here. Yeah. So basically what happening is like for log, you will access the element by index. Okay. And by ilog, you will uh, access the element by its position. It's just the access method of access. So most of the time what you will be doing is you will be accessing the elements by its column, because most of the times you will get the you have to put the operations in the data set or some editing. If you do some editing in the data, you will have to do it by column. Okay. So rows you can do, but most of the time while editing or accessing data, you have to use the column access. Okay. See, now all the values of age column are presented here. Okay, till 917. This is called column access. And these are the accessing by rows. Okay, I think in the newer version they have just made no difference between lock and iLock. But basically iLock is by position and lock is by index. Okay, yeah, as you can see here, iLock is index based and lock is label. Okay, so let's move on to the next. So yeah, earlier that I was saying, like most of the time you will be accessing data frame by columns because all the operations basically are column based operations. Okay, or you can also update a value by rows. Okay, so this is called modifying a data frame. Okay, as you can see in the example, we have used the created a new column called total and then just add the values of maths and science there to get the total marks. And also we can update the value by using log function at the index 1 and put the value of anything. Okay, and then delete the column. We will see that all these three things in the code. Df.drop means to drop the column. Access 1 in place is equals to access 1 means we are accessing by column. Access 1 basically means column. Okay, if we put access 0, it will become rows. Since we are always working in the columns, so access will be 1. Okay, and in place true means that we are removing this column permanently. What happens is, to you to understand in place, all these operations, like you will get in rows and this. So what happens, like if you put these operations, for example, mm, let's just take df. Okay, let me just print df here first. So we will take this small table as an example. And now, first of all, let's us go create a new column called total. Okay, total is equals to df dot max plus df dot df times. Okay, now if I print df here, see, you don't need to like first create the total um, column and then add the values. Pandas will definitely will just create a new column and then add it to a table. Okay, now, but let me ask you a thing. If this total column is getting added to the original data table, this is the table that we just created. So it's just a random. Okay. If I somehow like add this here in this, will it be permanently added there? Or if you one day, like suppose I add here some column, uh, let's just say by the name of total. Okay. With hard delete, I also add a column called total and then put some values here. Okay. Then if you go to the original file and try to access there instead of this here by using Python code, will the column that total I in the uh, put in the file using pandas, will it reflect on that file, original file? The answer is no, because these kind of datas are like important. So uh, any kind of permanent operation on these data can harm the data sometimes. Okay. So basically what I'm doing right here with all these data is I'm just uh, y- operating on some copy of this data that is in the memory. Okay. So right now, all this addition and all that, it will be just happening at the mm, copy of the data. If you still save it, for example, if I'm using here for addition, it will happen. Okay. I'm putting a column here, total and all that. It will be uh, it will be saved in the main memory, and it's okay. If you can always new data there, so it's fine. But what happens is when we try to drop the data, that means we are trying to uh, create a uh, like drop a column here, like deleting a column here. Let me show you with example. Df, let's just take df2. Okay, df2 equals to df dot drop. I'm giving the value here science, comma x is equals to 1, because that means we are dropping a column. And instead of just uh, using in place, I will be using in place in next example. I just do this. Okay, let's see what is df2. Okay, see, df2 is name, maths and total. Here there is no science folder. Okay, but what will happen if I print df? See, there is a science column. Okay, so what happened is I deleted a column from a copy, and I stored that copy in that variable called df2. Okay. Now I have two data frames, one which contains science and one which do not. Okay. So while dropping these columns, you have to keep in mind, like deleting data is a huge risk. Okay. So if you want to delete data, you have to first make sure the data will not be used. That amount of data that you're dropping or the amount of data you're deleting, wi- it will not be used in the future, or it is not useful to you anymore. Okay, that just keep that in mind. It's very important thing. Okay, now I'm not assigning it to a variable df.drop axis 1 is equals to 1, x is equals to 1. Now I'm using a keyword called in place. In place, what will in place true do? It will take a value of true, which means I'm deleting a data or column from the original table. Okay, which means that the data will be permanently gone. You can't access it no matter how hard you try. It will be permanently deleted. You have to, if you want to keep somehow want the data back, you have to write it manually, or somehow pray that you have another copy which has not been edited on somewhere else. Okay. See, now I'm in DF here, and it also does not have science folder here. Science folder is permanently deleted. Okay, if you want, I can just print it right here. See, science folder is deleted. Science column is deleted, and no matter how much I try, I am not able. I'll be not able to access the science folder. Science column. So when you try to delete some kind of data from a data frame or data, just keep that in mind. That 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 data is no longer useful, or it will not be useful in any case if you require it in any case. If you require it in the future, do not delete it no matter what. Okay, just keep that in mind. It's a very important thing. And yeah, there was another example, like how can we update the value here? Okay, so update is just basically you can use the log function if you want. Do if you want a particular cell or particular value to be uh, edited using log function. Here I'm giving the log, which means it will take two values. The which means one is index and one is the value that you want to put in there. Okay. lock one. Lock one means index one. Here in this Meena, I am editing the marks of math. Let's see here an example. Yeah, editing a marks of math equal to 90. Okay, the code has run. It means value has been updated. Let's see. See the value as index one, and in maths column has been changed to 90. Earlier it was 79. Now it's 90. Okay. And one more thing, if you're getting confused in like this, how did we use read, CSV, and head function that I just told you about and just skipped it, you will be learning in future lectures, maybe in the next lecture too. So it's just you don't need to like scratch your head around it. Okay. So how that's how you update the value by a particular value if you want. Okay. So we have practical use case here. As you can see here, we have some data, student data basically, with some student names, their marks in math, science, and English, and we create a data frame out of it. And now we want to find an average. Okay, so let's do it. First of all, let me check. Mic is on, right? Yeah, mic is on. Okay. So let's go to the code. Uh, let's just create a new data. Okay, data name array array Nina, Harsh. Five is enough, and we will give them some marks. Let's just say in math, 89, 90, 78, 90, 90. Yeah. Okay. And science, mm, let's just say 78, 78, 90, 78, 90. Okay. And then English, 90, 89, 90. Okay, I just 90, 80, and 90. Okay. Yep. Five values. Five, five. Okay. Now using this, we will create the new data frame pd dot using data frame function and the data there and then df. Okay. So we have created our data. Now we have to calculate the average of the marks. Okay. What will we be doing? We will create a new column. It's just giving a name and put the operation in it. Pandas will automatically create a new column in the background. Average, mm, is equals to df. There's one more thing. Like, I'll, if you are accessing a data frame using column by using square brackets. Okay. Now, what if you want to access them like multiple columns at same time? So what you will do is like go inside and give another list inside the like list parenthesis and square brackets, and then write there write those uh, columns there. Okay, instead of just going single column by single column, you can also do this. Uh, yes, see, now I can access these three columns at the same time. Just inside, I have given a list of columns. Okay, inside the square brackets. Dot this, and there are many member functions here. You can just practice it like what these functions do. We will be using mean here, mean, and as we were saying example, we will taking axis equals to 1, which means we have to column wise uh, column wise operation. Okay. Now if we print df, see what happened is now we calculated the average of where each and every student's marks. Okay. Now if we take this, Ray has a total average of marks of 85.667. Okay. If you find the average there, let's just say 89 plus 78 plus 90 divided by 3 is 85.667, same value. And similarly, Joy also have average marks, Meena, Shiv, and Ash. All these have some extra marks, sorry, average marks calculated here. And this average named column is already also attached to the table. So these kind of operations are there. These are the most basic one. These are the kind of operations you will have to do when you will be working on a data that is supposed to go to the machine learning model for its training. So you have to make the data ready for that. Okay, you have to find columns, some remove some columns or change the type of the columns. You will learning about them in the future lectures. So this is a test real world example, like what kind of operations we have to do on the data. Okay. So next, now you have here, this is your assignment for this lecture, and you have to create a data frame for students. Okay. Now you have to take the data, create a data frame for 5 students. Okay. As we did in this lecture, just here, create a data for the 5 students, and you have to take 5 columns. Okay. Name, maths, science, English, total, and average. You can create total or average functions as we created in lecture. It's totally up to you. Calculate a total marks per student and average marks per student. So basically, these are the two things that we did in lecture. You have to just practice it again and print the final table neatly. Okay. Save your data frame as a CSV file using dft.toCSV. Okay. Let me show you this. If I want data to be saved somewhere in the folder, I can use the df.toCSV and just give it a some kind of name. For example, exam lecture example dot csv. You have to also mention dot csv. Okay. Now see, but just by writing this operation here, lecture dot csv is saved. See, your data is saved here. Okay. So you also have to do this and then submit the exam assignment. And there's also one more thing, you have to do it with both series and data frame. Okay. Getting it? So this is your assignment for this lecture, and we have reached till the end. Okay. So any doubts?
No, sir.
Okay. So thank you.
Thank
And
you, sir.
the example assignment on time.